Hey guys, so this is my first progress video log and a brief rundown of my system. This video was created mainly for YouTube user TheAlphaPyro to give a brief rundown of how my stepper model or servo stepper model is integrated into the system to control the butane fuel. So without further ado, these are the basic components of the system. This is an Arduino board. Well, as you can see here, this is an Arduino clone, actually a Arduino, which I'm just using for prototyping purposes. I will get a different board later on, or a more compact one, which I can solder the wires directly onto it. And then these here are nothing, just an LED indicator and so on. This is a ULN 2004 transistor which is used to power the stepper model. Basically it is drawing power from these four AA batteries, which provides since these are rechargeable batteries, they provide 1.2 volts per battery, which accumulates up to 4.8. This stepper model is a 5 volt rated stepper model. It draws 550 milliamps per cycle, per step. So the Arduino can't supply more than, if I'm not mistaken, 50 milliamps. So if I were to draw the power directly from the Arduino, it would fry the board, and that's why we need this 2004 ULN transistor Darlington array to draw the power from these batteries. So basically, yeah, that's how I'm doing it. This is, I couldn't do a direct connection from this stepper model to the lever because previously I did that and it didn't have enough torque to push down on this lever, to pull down on this lever. So basically I halved the load by making it into a movable pulley sort of thing. Yeah, and well, it works, except that I get a slightly slower reaction since it has to travel double the distance. But for testing purposes, I think it's perfectly okay until my final product is out, which isn't gonna be so soon. Oh, and one last thing is the last component. This is the flex sensor. As you can see, you can't see much out of it right now because I wrapped it in shrink tubing. Reason for this is because it kind of gets affected by my sweat when I tape it directly to my hand, so I had to use shrink tubing to prevent it from getting wet by my sweat. So yeah, that's about it. Basically what happens is, I'm going to boot up this thing first. When it boots up, it enters a detection mode right now, which I can, if I move the sensor, it will enter a calibration mode, which finds the minimum and maximum for the sensor. So right now I'm getting a min and max. It lasts for about 4 to 5 seconds, and then we are ready. So this is currently the sensor is currently straight, or I have to force it to straighten a bit. Yeah, so basically when I bend the sensor, that happens. The motor turns and it pulls on the system. So you can see it, you can hear it, the gas is coming out. The LED is nothing, you can ignore that. It's just an indicator to make sure the sensor is getting input. And yeah, that's basically it. Right now the hardest part to make is the nozzle. For any palm mounted flamethrower thingy, as many people have said and done before, the nozzle is still the hardest part to obtain. So yeah, basically that's it. Of course this isn't going to be on the final design. I'm just using this to hold down the motor while it pulls down on the lever. And yeah, I guess that's about it. Anything more, and I'll maybe post it in the description below. Okay,